Okay, welcome to section 12.3. We're going to be looking at geometric sequences today. Last class we did arithmetic sequences, and we're going to use The Walking Dead as our example. So on the TV show, there's a disease that's going to turn people into zombies, okay? And where our assumption is that if The Walking Dead bites a human, the human turns into a walker. Assume that each walker turns one person per week into a zombie, and that none of the walkers are killed. So we've got a town with 150 people, and each box represents a human. So first week, there's one walker and 149 humans. So that's this dark box. The following week, that person infects one. So now we have, after the end of the first week, we have 2 people infected and 148 are not infected. At the end of the second week, those 2 each infect one person. So now we have 4 people infected and 146 not infected. So I want you to finish filling in this chart. So pause the video while you finish filling it in. Okay, and then let's come back once you've got that filled in. How does our walker population change each week? And how long will it take before everyone in town is a walker? Well, it's doubling every week, and the town will all be walkers somewhere between the 7th and 8th week. List the number as a sequence for the first 5 weeks. So it's just 1, 2, 4, 8, 16. And if we were to write a recursive formula for this, my first term is a 1. Again, so a sub 0, the very first term at time 0 is 1. And the recursive formula then is the nth term is I take the n minus 1 term and multiply it by 2. If we want to graph this, here is the graph of what this looks like. Ignore these 2 points because they were a mistake. So here is our graph of what is going on. What x values are used? Only positive integers, non-negative integers. And the y values are all values of 2 raised to some power. Okay, we're going to do the same thing here. So now we've got a different town, and this town starts with 3 different people are infected. And again, you're going to make the same assumptions. Each week, each walker infects 1 human. And so we want to fill this out to show what happens. And again, so after 1 week, those 3 each infect one, so now there's 6 infected, and there's only 144 humans left. And again, pause the video and finish filling this out. Okay. How long will it take in this town for everyone to become a walker? Well, this town, between weeks 5 and 6, everyone's become infected. The number of walkers as a sequence, so we're just listing the values here, 3, 6, 12, 24, etc. Write a recursive formula for the sequence. Okay, so this one, my starting value is 3, and my recursive formula is that I take 2 multiplied by the previous value, or the previous term. If we had an infinite number of people who could become imagine that we have an infinite number of people. We want to create a sequence to show what happens if we start with 4 people infected at week 0. We want to show weeks 0 through 5. Well, you can see I've done a lot more than that. So this is week 0. After 1 week, we now have 8 people infected, then 16, then 32, etc. The recursive formula for this is that my initial value is 0. My nth term is defined as 2 multiplied by the previous term, the n minus 1 term. So exact same recursive formula. The only difference between all 3 of our recursive formulas is the starting value. How many walkers will there be in week 8? Well, again, we just multiply these out to see. 1,024. Week 13, 16,384. In week 24, 33,554,432. And if we wanted to find a formula for this, we could. The nth term is defined as 4 multiplied by 2 raised to the n minus 1 power. And rather than multiplying all these out, we would much rather use this formula. And so we're going to investigate that a little bit more now and formalize this. So our geometric sequences and series, you must multiply each previous term by some common ratio to get the nth term. So again, if I want the 10th term, I multiply the ninth term by some common ratio. And the way we find that common ratio is to take any term and divide it by the previous term. So I could take the second term, divide it by the first term, take the fifth term, divide it by the fourth term, and I will get my common ratio. And because there's a common ratio between these terms, instead of a common difference, that's what makes this a geometric sequence versus an arithmetic sequence. So we want to show that these sequences are geometric, so we've got to find the first term and the common ratio. Well, my terms are written out here. So the first term was a 2, second term was an 8. To find the common ratio, I take the second term and divide it by the previous term. So 8 divided by 2 gives me 4. That is my common ratio with the initial term of 2. Likewise, if I'm doing the same for this sequence, I've got to first plug in values of 1 and 2 for n. So if I plug a 1 in, 3 to the 1 plus 1 is 3 squared, which is 9. The second term of the sequence is going to be 3 raised to the power of 2 plus 1, so 3. 3 to the third is 27. To find the common ratio, ignore that. That's hard to read. It should be the second term divided by the first term. So 27 divided by 9 gives you 3. So the common ratio is 3, and the first term was 9. Go ahead and try this next one yourselves. Find the first and second terms, and then divide the second term by the first term. And you should find that the common ratio, well, the first term, when we plug in a 1, we get 6. Second term is a 12. Divide the second term by the first term, and we get 2. So the common ratio is 2, and the first term was 6. To find the nth term of a geometric sequence. For this, we take the initial term multiplied by the ratio raised to the n minus 1 power. And this should look familiar. This is what we had with our zombies with an infinite population when we started with 4. Okay, and let's take a look at this. So if I want to find, I've got this sequence defined here, and I want to find the nth term. Well, I need to know the common ratio first. I can see the first term is 3. But to find the ratio, I'm going to take the second term, which is 2, and divide it by the first term. So the second term divided by the first is 2/3, so that is my common ratio. And now to define the nth term is defined as the initial term, which is 3, multiplied by the common ratio raised to the n minus 1 power. If I want to find the ninth term of this sequence, well, the ninth term, I'm going to just plug this in. 3 multiplied by the common ratio of 2/3 raised to the n, which is 9, minus 1. So 3 times 2/3 to the 8th power. When we raise a fraction to a power, both the numerator and the denominator are raised to that power. So 2 to the 8th is 256. 3 to the 8th is 6,561. Multiplied by the 3, well, the 3 is the same as 3 over 1. The 3 and the 61 are both divisible by 3. So I end up with 256 divided by 2,187 as the ninth term in my sequence. If I want to find the recursive formula, again, the recursive formula for a geometric sequence is simply your common ratio multiplied by the previous term, or previous term multiplied by the common ratio. So to get to the subsequent term, you always multiply by the common ratio. And let's take a look at the last page now. I'm sorry, the font on this got really weird. But if I want to find the sum of the first n terms, so this is where I'm adding terms 1, 2, 3, 4, 5, all the way up to the nth term together. So in this case, the first term is always a sub 1. To get to the second term, you multiply that by the ratio. To get the third term, I take this and multiply it by the ratio. So r times r is r squared. My fourth term would be this multiplied by r, so it'd be r to the third power. So you continue up, the nth term will have n minus 1 as the ratio. And a simpler way to do this is the answer is going to be your first term multiplied by 1 minus your ratio raised to the nth power divided by 1 minus the ratio. And notice your ratio cannot be 0 or 1. That's not much of a geometric sequence then. So we're going to try and find the first 10 terms of the sequence 3 to the nth power. So n is going to be 10. Here we go. So the sum of the first 10 terms is equal to the sum of k equals 1 to 10 of, and again I'm plugging into this equation, the first term was 3, times 1 minus the common ratio raised to the nth power over 1 minus the common ratio. And we're going to try and simplify this a little bit. So 1 minus 3 gives us a negative 2. We still have this. The negative 2, and we multiply 3 times 1 over negative 2 to bring that out. And I've got 1 minus 3 to the 10th still in the numerator. Well, we go ahead and just put this in the calculator, and we get 88,572. And honestly, I could have left the negative 2 under here. That was just personal preference to pull it out. Okay, so now example 4, we're going to use our graphing utility, our calculator, to find the sum of the first 15 terms of the sequence 1/3 raised to the nth power. Well, so here's what I'm looking at, 1/3 plus 1/9 plus 1/27, etc., all the way up to 1/3 to the 15th power. So here's what I'm looking for, the sum from 1 to 15 of 1/3 times 1/3 raised to the k minus 1 power. So to do this, we're going to press math on your calculator. Let me grab mine. Okay, so we've got our calculator, and we're going to go to the math button. So over here on the right, let me put that up, so math. And if we come down to option 0, summation, and we're going to go from n equals 1, and it says n because I'm in the sequence mode, to 15, because we want to add the first 15 terms together. And in here, we're going to put our sequence. And our sequence is 1/3 times 1/3 to the k minus 1. So parentheses 1 divided by 3, that's the first 1/3. And that's my initial term, multiplied by another parentheses 1 divided by 3, raised to the power, so the little caret symbol, of n minus 1. So that's my sequence entered there, and I'm asking the calculator to add all these together for me. I press enter, and there is my value. So the sum of the first 15 terms of this sequence defined as 1/3 raised to the n power is 0.499999652. Okay, so if you have to add a certain number of terms together using the summation button, which is found by pressing the math key, again, the math key, and then choosing option 0. So you can either arrow down or you can arrow up, and it will bring you to the bottom of the list. So there you go. Okay, and you'll go ahead and enter it. Okay, the homework is section 12.3, and it will be due at your next class. This is your very last homework for this year. Have a good day.